Hello everyone, this is my ICP number 9 for Big Data Analytics. We were supposed to do linear regression on this ICP and find out the best fit line, root mean square error, y-intercept, the slope of the equation and all that. So I imported this dataset from GitHub source. It's about a weather dataset. I have like two dependent and independent variables. A temperature column is basically my x values and humidity column is basically my y values. So data.describe just to see if there are any null values. Data.info is also doing the same. What I am trying to do is basically dropping those null values here, and then I am basically splitting my data into my x and y. So my x is basically temperature column and my y is basically relative humidity column. So their shape is given as 192 comma and the x shape is also the same. So now to find the slope of the equation, I have this formula. So what I did is basically made a function with this name and then just use some maths libraries to find this. Similarly, likewise for y-intercept, I have done the same, just implementing the above equation into mathematics. And for the now I'm calling that function to find the slope of x's and y's. So I've got my slope as minus 4.05 and my y-intercept is 195. So what we're left with according to y equals to mx plus b is basically r squared error. To find the r squared error, I have used this equation. This is where this equation is being r squared error is being found, and this is just to calculate SE squared error. And now this is basically to calculate coefficient of determination that is basically used in squared error. So I define that according to this given above equation. You can see like each step is basically doing the same. Now I'm calling that r squared this coefficient determination here, and this will basically print me the r squared error and SSE as well. So the best fit line is shown below as well, and now it's time to basically train your model. For model I was getting some errors, so I had to reshape the data, and now I'm splitting the data into 33% is my testing size. Once I split it, you'll see the best fit line and mean square error. This is our best fit line accordingly, and these seem to be inversely proportional. So this was the ICP. Thank you.